Maybe let's start with introducing ourselves, maybe talking a little bit more where we're coming from, what we're doing, like on day-to-day job, so that we know a little bit of a background, right? Um, who wants to start? William, maybe, yeah?
Hi, I'm Will Benton. I work for Red Hat. I'm based out of Madison, Wisconsin, in the Midwestern U.S. And my day-to-day job is sort of thinking about how people are going to put machine learning into applications in the future. So I'm an engineer. I lead a team of engineers and data scientists, and we're sort of focused on like, well, how can we take these capabilities? How are application developers going to make use of this? And so the motivation there is that if you look at the last decade of AI, with techniques like, if you think about neural nets for image recognition, or you think about word to vec, these are all sort of these really exciting things that were beyond the scope of AI 20 years ago, but not within the last decade. We're all driven by application concerns. And I think that the way that people are deploying AI is increasingly as part of an application. But there's still sort of an huge mismatch between the way people develop techniques and the way they build applications around. So that's what we're looking at.
So as for the business value that you want as a company to provide with that respect, what it is, do you want to have a product that, or how, or is it like internal usage?
Well, so yeah. So I mean, I think we're focused on sort of proving out our theories about how people want to build applications by building internal applications. Our work is all in the open source community, though. I think Red Hat has a lot of developer tool offerings, a lot of infrastructure offerings. We want to make sure people think I can use that for an AI application too.
So on one hand, so essentially you have an idea of how it should be done or could be done. Then you implement it as a product inside the company, and then you open source part of it, I guess, right? Probably not the whole thing, or is that the model?
Well, what we've open sourced is we've open sourced tooling for running Spark clusters and containers in the cloud or on premise or wherever, and managing them. And we've open sourced some libraries taken out of, I mean, the internal applications we've done are dealing with internal data and internal schemas, and we can't publish those applications, but everything else we do is open source.
All right.
So like we've extracted library, if we had to solve a problem more than once, we put it in a library that's built against the latest version of Spark, and people can use it. We have TensorFlow and Jupyter images that you can run in the cloud. Um,
Yeah, that's interesting. So what's the driving force be, behind actually putting that as an open source? So it sounds like everything that you do, you
Yeah.
put as open source. Is that right?
Yeah, I mean, we believe in that, right? That's sort of,
Okay.
if we default to doing things in upstream communities, we default to doing things as open source.
Okay. Okay. Cool. All right. Yeah, that's a question. Sorry.
Hey, Conrad Fabianchik. I was born in Krakow, but I grew up in the States. I currently am the key account manager at Epsilon Data Science. And a few years back, I co-founded Craftinity, which Matthew actually spoke for earlier today. It's a deep learning startup. And my job is to basically work between huge corporations and our engineers and figure out what's the solution that we can provide. Because we may be a software house, but it's not the case where companies come to us and say, hey, we have this data, we want X, Y, Z. It's more so the case where they come talk to us, and then I'm just like, okay, so what do you have currently? And you want to do something. You don't know what that is, and our job is to basically tell them what that usually is. In terms of how I see it usually works, most of our clients are Fortune 500 or large enterprise clients, and most of the solutions that we do are not deep learning because most companies aren't ready for deep learning. They're mainly trying to get there. So Gartner has a really good kind of 4-step where you have descriptive all the way to kind of diagnostic and prescriptive. And it's basically with ice cream, a good example. So one will tell you how much ice cream you had last month. The next will tell you how much ice cream you need to buy. The third one will start buying the ice cream, and the fourth one will already buy all of your ice cream so that your clients can just buy your ice cream from you.
Or eat it yourself, I just thought.
Yeah. But yeah, I think that companies are really starting to realize that there's a lot of benefits to machine learning and deep learning. But as I said, it's still developing, and there's not really any kind of mentality as to how these products should be created. And as you said, it's always kind of the application focus at the end of the day. That's why we make sure to always build an interface or a model or a visualization, because at the end of the day, if business doesn't see a need and a benefit from what you're building, then they're not going to pay for it.
Okay, so it's pretty cool. So you have a good overview of various clients, right? Because
Yeah, we
yeah,
work
you were dealing
in
with.
we're cross industry
Mhm.
by choice. So we're industry agnostic. We work primarily with companies from healthcare, finance, logistics, real estate, so like corporate real estate, and with government clients. So for example, Boston Consulting Group or the government of Canada. So it's really diverse, and that's actually useful for our clients because we're also providing know-how from other industries because it's not always about what you provide in terms of the model, but it's how you can actually benefit their business to implement it and also assist the person who's leading the project internally within the company sell it to their boss because at the end of the day, they're also accountable for their purchases.
Okay, so if I understand correctly, the guys come to you and say, "Oh, we need this AI," and you tell them you're not ready, more or less.
We try to educate them. We try to educate them as much as we can.
Okay.
We try to kind of show them that repeatability, process orientation, data validation, cleaning their data, having some sort of focus, and essentially making sure that at the end of the day they're not trying to achieve some sort of accuracy precision, but rather validate a hypothesis. That's kind of what we try to focus on when we discuss it with them. And it's not like we want AI. It's more so we know we want something. What is that? Or we know we want something with, for example, let's say insurance. We know that we want something with the way that our sales agents handle our clients. Can we, for example, do some kind of sentiment analysis and try to plan out routes that certain clients can take to achieve certain results? So they might have some sort of idea of what the end goal is, but they don't necessarily know exactly what it is they want in terms of the actual technology.
Okay, cool. All right, yeah, we're going a little bit beyond our introduction, but I think that's good. Yeah, it's very lively. Okay, Umi, do you want to go next?
Sure,
And
sure. So I'm Mehmet. So I'm from Turkey. I grew up in a city called Izmir. I'm actually still Muslim, like every time when I talk about it. But I ended up in Poland because I came here like for my studies. I'm an engineer by trade, and I did some mathematical finance as higher studies. I worked in like different industries. Like I worked some consulting, supply chain management. I did for some time high frequency trading, and I ended up in IBM, and I'm now working as a data scientist. I'm a part of a global team called IBM, a data science elite team. So our role is a bit more like enablement, like when clients are facing with really like complex problems, right? And if you look at the last, let's say 15, 20 years, right? So now we were using some flat reporting tools, then we had some BI analytics, right? BI intelligence tools. Now the natural evolution of things are, requiring some more advanced methods and techniques so the companies can get more out of their data. So our team is actually like going on site, uh, working side by side with the clients, and we would like to make sure that the business outcomes that they would like to get are in line with all the technical projects that they have in place. Right. So I think the IBM strength is it's really strong in enterprise space. It has a lot of clients from different industries, so we got a chance to see like a lot of different use cases, right? And I think the main problem for me is like once we go to the clients and get some executives on the table and talking about really fancy algorithms or like new techniques, they don't usually understand. So we need still a lot of people with soft skills, right? Like the project management, leading the projects, like getting together key people in the organization and then make things happen. Because I don't necessarily think that we are lacking the talent. Like I can speak for IBM as well, but what we are usually spending time is just the organization things, right? The management side of things. So, so that's what I do basically. So we're working like healthcare, law, the finance. Like we work a lot with the government, university partnerships. So this is basically it is, and the adoption is like taking off. I believe it's not linear at all. It's exponential. It's coming, but it will take like I think a couple of more years to really understand the power of what machine learning can have.
cool. Okay. Yeah, I guess we're going to go to those at one of the topic questions, but it sounds like quite a lot of what you do is actually not what you want to do. Is like dealing with organizational sort of issues to actually get the stuff working. Or
Actually, I really take a lot of interest in like managerial side of things because the thing is like we're not building rockets, right? There are like a couple of use cases and there are a couple of algorithms and there are a couple of issues regarding like how do you really pack all of them in in like a couple of products and deploy them into the production. So it's not like, so we have a lot of course, research activities, right? We have IBM research offices all over the globe, but usually what we end up with, so we need to have interpretable models in place, working with an acceptable accuracy. And the end users are actually using that because there are a lot of legacy software, and people are resisting sometimes. Here, look, we have a like better product, we have better algorithms. So, but they just don't know how to use across like all organizations, all those technologies, right? Because they have too many. Let's say they were talking about spaghetti code, so spaghetti infrastructure, right? So every department uses something else, and how do you really combine all of them into one? And especially data, right? So making data ready for machine learning and AI, it's really pain because you usually need to gather data from different sources and get them together. And in finance, it's very strictly regulated environment. I mean, you cannot play around with data like you do in your local environment, right? So we need definitely more tools around data governance, right? Unified governance and all like enforcing those rules and restrictions across the organization and doing it from one place. And um, so we are still at like the adoption of these data technologies. I think we're shifting from like traditional database management to like let's say unified data management and governance tools. So we are thinking a lot about it actually, and learning a lot as well from our experience. So this is the mainly the part that we actually focus. But of course, AI is a new shiny thing. I think it has like 4 or 5 years more to still stay on the top of the things. And of course, like it's a it's a different world. IBM is a different world. I would love to hear also the other stories, like how do they really deal with all these AI projects, and what are the really challenges. I'm sure that we're gonna hear a lot of different things, especially yeah. Cool. Yeah, cool. Sure.
All right, so I'm Grzegorz Gawron from Virtus Lab. My background is in computer science, but also economics. I spent a lot of time working on trading and risk management systems in banks, and then I moved more into big data. Currently, what I was talking about at the presentation as well was this use case that we're working on, which is a big retailer. There is a lot of optimization happening, like from what they do. There's all the prediction of the data and features they need to do the optimization. So quite a lot of use cases, and probably that would be the from what you were talking about. Actually, a lot of things ring the bells. Very very similar stuff. Okay, cool. Right. So what do I have here? Right. So the first stuff, probably we talked a little bit about that, but maybe if you have some concrete examples in your mind, I was thinking about this AI adoption limits, right? So is it technology maybe? Is it organizational? We've heard, probably there's a lot of organizational stuff in there. But how do you see that? Do you have some, examples in your mind?
I think it may be social and cultural, and I can expand on both of those.
Mm-hmm.
But I think the sort of social there are two kinds of social difficulty. If you have, and I'm coming at this from the perspective of AI is going to be driven by application concerns. That's my bias. I'm not trying to hide it. But if you're going to put AI into production in an application developers are going to be an important part of that. And if we have this sort of cultural thing where you say AI is this crazy impenetrable thing, I have, we had in the last talk a really good example slide that was like, this is really intimidating with a bunch of LaTeX math code in it, right? Like that's not, you don't have, you can be an engineer and use engineering best practices that you adapt for AI. But I think that's the other side of the problem is that like if you have a conventional application component and one of your dependencies stops working or your code bit rots, you know right away because it fails a test or it crashes in production and then you write a test, right? If you have a model, that model could happily continue giving you the wrong answer indefinitely.
But on the other hand, is it not possible maybe to test out the model a little bit, on the cases that it should behave properly?
So I
that
think,
sort of thing, right?
I think this is sort of the cultural thing we need, is we need
Yeah.
to sort of incorporate, the sort of practices that people have built for continuous integration,
Exactly, yeah.
continuous deployment, continuous validation, and expand that to treating.
So essentially just treating that as a module that needs to be tested, just part of the solution.
Yeah.
Yeah,
but
But
if you,
quite, yeah.
sorry, go ahead.
No, quite a lot of the current practices actually apply in this case as well, right?
Yeah, I think they do, and I think that's why I'm sort of feeling good about the future. If something that is in the hands of application developers, because it really is just learning some new habits and adapting some old habits.
Okay. So on that front, there is no problem of a limit or, a big difficulty, right? On that front, it looks good from your perspective.
I think from that perspective, yeah, the issues we have to overcome are not insurmountable. It's the kind of thing that we'll need better tools. But I think that, when you have a popular area like this, the industry and the open source community have really shown a readiness to provide those tools and to teach everybody.
Yeah, and that's actually pretty interesting what you're saying, because an example from our side was that, there is a team of data scientists writing the models or creating the models. And then, historically they were just creating that in, I don't know, Jupyter Notebook, then running them more or less manually, and then using the predictions out of that model also more or less manually using them somehow, right? Um, and well, some of those models were tested in some way. Some of them were not really tested that much, I guess. And what I find interesting is that we're talking about this those best practices coming from software engineering perspective. And when we were talking to them about that, right? I mean, they were really into the idea of, oh yeah, let's put some tests around that as well, and just add that on. So I think maybe there is this different viewpoint of a data scientist as well when they work with the model. Okay, let's just get the model working on some sample data, and this is a great model, right? But yeah, this additional, let's say, testing layer on top of that, I think is a very useful feature as well. But yeah, it's let's say software engineering perspective in a way on this. But we need that, right?
What I'd like concretely, I guess, if I wanted to make a request to the community is better support for testing things where you can have an error bar around the test result, right? Like if I
Yeah, the only thing probably which is different is, okay, let's say your test fails, and now what? I mean, you have this box model, okay, let's come back to the drawing board and try to, yeah, okay.
Yeah.
Yeah, we can try and start. Is there, okay. Well, okay, cool. Any other thoughts, guys, on the, limits of AI adoption limits that way?
I'll jump in here. So we see three big limits. One of them is when it's a bottom-up versus a top-down initiative in a company. So when an engineer decides that he wants to build something and impress his boss, that doesn't get as much support from management as when management decides that it's important. That's a big issue, because if we don't have necessary stakeholders or people that are involved in actually A, signing the check, B, using it, we always try to get users from day one involved into telling us what they need, because it's not, as you said, it's not just a siloed data science model. It has to have some sort of application, some sort of interface, visualization. So we need to have business buy-in from day one. They need to know what to expect, and if not, then we're just kind of plowing away with an engineer who has a pipe dream. A second big issue that we see is access to open data. There's a lot of data that we could be using to train certain models, but because of, let's say, regulatory restrictions or because of security issues or HIPAA or GDPR, we're limited with the types of data that we can access. But there's a ton of data, especially in the government sector, that if it were properly prepared, and I don't mean properly prepared, but properly kind of hosted, where we can download it and use it easily, that would really speed up the benefits that we could experience. And thirdly, lost my train of thought here. Yeah, those are my two big ones, I think, right now, but it might come to me again.
Yeah, exactly. It might, and maybe I'll just add in one thing, the openly available data. I was really surprised at some point when I wanted to use some weather data, historical, and I just couldn't find it. I mean, it's not possible. You have, at least in Poland, I'm not sure, maybe in the US or in some other places,
you can do that, but it's very difficult. And you would think, every day, I mean, you could have some scraper and just scrape every day some temperatures or wind strength or direction, but it's not available. I was so surprised. So, yeah.
I'm happy to see that satellite data is getting more and more accessible and more cheap. Right now, the resolution is 1 square meter, I believe, per pixel, which is really good. And right now, we're using that data for insurance purposes. So it's really fun to see is that you can get new types of data. Obviously, you have to pay for it because open source satellites aren't that great. But it's still developing, and satellites also develop with Murphy's Law. So they're also going to develop at a really nice pace.
That's interesting, yeah. I didn't think it is so easy to actually get that data. Umit, any?
Yeah, I think, that's an issue. And that's a popular saying that data is the new oil, right? Whatever you get, it's yours.
So AI or data is the new oil?
Data, I mean, I think first the data, right? Because without it, like, you cannot apply anything. So, I mean, a lot of companies are focusing on collecting this data, transforming this data, and selling that transformed data to the clients, right? In my case, for example, when I'm thinking about the finance, I'm just buying a lot of financial data for my own research, so I have to pay for those, right? Because, for example, let's think about the stock prices. I mean, you can get daily data easily. You can scrap your minute level data, but what about second, millisecond, microsecond level data? So you have to pay for that. And this is not really cheap. I think that it should be cheap, but it's really not. And I think it's similar for the other kinds of data, right? So in the morning, so we were watching Professor Leshkov's presentation, and there were those like big machines, and they were having those sensors on it, like thousands of sensors on those big machines. So if you'd like to get your hands on that kind of data, it's not available. They will not even sell it to you, right? Because it's so valuable. So I think it's really domain specific. So whatever your domain is, that you really need to focus on what you can really get out of it, because it will be yours forever. And the insights that you will have from that data, it will, no one else will have that. So I think it's very important.
Okay, so,
Yeah.
So essentially, to summarize what you're saying, data would be this limiting factor, the biggest limiting factor, access to data. Mm-hmm. Okay, cool. Yeah, from my perspective, what I've seen. Data is definitely one thing, but it's also sort of organizational, right? So it's, I don't know, there needs to be an appreciation that actually to build something more advanced, like doing some predictions, there is a lot that you need to do in terms of finding that data, preparing that data, getting access to that data, and that's a big project, right? It's not something very quick that you do. And I think if someone, as you were saying, right, you need to get the business buy-in for doing that. And I think the problem might be as well that business, doesn't, is not very up to date. Maybe what the thing can do and what it requires. What sort of scale of a project it is. Yes, so maybe that is one of the things.
That's true. Easy thing to remember, garbage in, garbage out. If you don't have good data, your model's useless. But in terms of business buy-in, what we found works best for companies that are a bit apprehensive or scared, either to A, give us their data, or to B, invest a lot, is to just start with a small proof of concept. Prove that this makes sense as a direction of investment. Otherwise, it's kind of just shooting in the dark. And as we heard earlier in the presentation, earlier in the day, building models without any goal in mind and business context is just kind of research. It's just fooling around with your models.
So how would that work? So you would talk to the client and understand what they need, and then you would say, okay, I know, I'm going to build a POC for you, and you're going to like it.
Yeah, so we basically ask them always for either A, anonymized data set, or post-NDA access to their data, and that's when you can actually tell them, okay, do we have the data needed to build a model? Because we're not going to promise that we can build a solution if they don't have the data. We can A, buy the data, scrap the data, or they should have some sort of data set, but that's always the first question is, where's the data coming from, and is it even high quality? And as you said, we always focus on testing, continuous integration, and we from day one try to add data validation, so we test our models, we test test our data, and every day when there's a new data set, or even kind of on a regular basis, managers get reports that validate every step of their data. I have a really good example. We built a pricing model for a Scandinavian company. They sell parts, wholesale, so B2B, and this was actually talked about yesterday by Olga on her presentation on scaling Shiny apps. We had to build tests for even basic things like, is the discount positive or negative? You'd be surprised how often data sets that were even kind of manually entered just have basic errors. So even from basic tests to the most complex, okay, does this result even make sense? If we're trying to predict the accuracy or the percentage of somebody kind of churning from your company, 105% doesn't make sense. So it's just even logical, basic, fundamental tests that are important.
Oh, that's pretty cool. So essentially what we're saying is, okay, tests for the model and tests for the data, right? That's, yeah, a nice...
Yeah, I think a good tool to see, or the tools that have proven useful are sort of data profilers, right? Where it's really easy to get a picture, not just of the sort of distribution of individual fields, but like, you can do anomaly detection on fields, you can do anomaly detection on the structure of values in fields. I mean, like, you're ultimately going to be imposing types on unstructured data, and the easier this process can be to figure out where the headaches are going to be, the quicker you can get results.
All right, cool. Anyone from the audience, any ideas? Just shout if you have something on your mind. One thing you probably need to leave at some point, so just feel free to...
in 5 minutes, I'm going to be ordering a cab.
Exactly, because Conrad will need to catch a flight. Yeah, okay. Right, I'm just checking what else I had there. Right, so another thing I was thinking about that could be interesting is, like, from your experience, do you see a difference in usage of AI, machine learning, more advanced analytics across companies? Is there some patterns? Like bigger companies, I don't know, probably easy pattern, having lots of data, trying to do that, but maybe some of those bigger companies don't actually use that data. I don't know. What is the requirement, or what is the pattern in the companies that successfully use data?
So my take on that is that it's really like a collaborative effort, like what kind of data set that they have. So it all starts, I mean, let's take a step back. It starts from the all like business understanding. Like you go into the organization and you're trying to find what's really happening with all the stakeholders. I'll give you an example. For example, even if you have all the data inside the company. So for example, supply chain management. Think about like two different organizations, like product supply and the sales, right? Now, the common goal of the company, they improve the sales, right, eventually. But these sales guys will come with, for example, okay, we're going to launch a products in the next 3 months. And we want, like, I don't know, 100,000 of this SKU. And product supply might, okay, go ahead and produce that 100,000, right? But if sales forecast will not turn out to be true, then they will be left out with the inventory that they will be scrapping at the end. So a lot of times they have conflicting goals, right? Inside the same company, and they are running towards the same goal. So I think, so with all the things that we are doing around like data understanding and the data preparation, some of the companies need just a little data because they have like obvious patterns that they don't need like a lot of data to understand that. Some other use cases needs a lot of data. Sometimes they don't have enough data, so we decide, okay, you need to get more data or maybe more quality data. So you are actually kind of sometimes blind when you go into the big organization what you can use or you can't use, right? So you really have to understand and figure out. That's why we are having a lot of workshops at first step with the clients. Like we are trying to map out all of their processes, and when we do the project, how they will be, addressing all the business outcomes that they wanted to see at the end. And then we decide, okay, what are the key people that we should include to achieve that objective? So it really depends on the use case. So again, for example, if you're working with a sales forecasting, right? Some of the high runners, like popular products that always sells well. I mean, you know that it's going to sell well, and then, but for some others that are not selling well, you're not quite sure, right? So I think for me, from my experience, it's always like use case specific, but you should always be really aware of this different organizational stuff, and then just to decide it correctly. Yeah.
I'm going to answer your original question as to what kind of trends we see with our companies. So obviously big, huge financial companies, obviously healthcare companies, but really surprising industries are, for example, maritime and shipping. This is a traditionally very old school business where people have relationships built over 30 years. These kinds of traditional hard, like mining, oil and gas, shipping, logistics, freight, these industries all realize that they're sitting on tons of data and they're trying to kind of be the number one. Merck is a great example. They hired just a small team of data scientists and in their first year saved $2 million. So that's a huge kind of ROI on that, and companies are trying to catch up with that. Those are the nice examples where it's a surprise that you're not expecting that kind of client to be interested in that.
Yeah, I think getting back to like different kinds of customers and how do people use data and get out of data, we've worked with a lot of internal customers on my team, and we've worked with a range of different kinds of people. We've worked with people who are domain experts and have collected a lot of data and figured that there must be some value in there, so we'll get some data scientists looking at it and experience with that. We've worked with teams that have had really sophisticated data scientists and good engineering pipelines, but you know, maybe their techniques are not scaling out, or they have problems on their backlog that they don't have bandwidth for. So we've done all of those kinds of things, and I think the interesting thing we've seen with the customers who are looking for data science expertise and maybe have a lot of data, but you know, sort of think that there's something to find there, is calibration of expectations is really important. You know, you might have, if you have performance data from a whole data center, you might say, I want to detect when a machine is about to crash. Well, that's a really hard problem, right? You might not be collecting the right information for that. Depending on the granularity of data you have, the machine could crash and come back up, and you might not even know, right? Depending on what you're collecting. But I think the really interesting thing to do in those cases is to work with domain experts to find problems that are achievable and that can create value and help them understand more about their infrastructure, more about their business, more about the world. And this gets back to what Amit was saying about interpretable models, right? Like this is something we all want to talk about, but like, what does it mean for a model to be interpretable? I think sort of pointing someone to something that either reinforces something that the domain expert already knows or gives them confirmation for something that they suspected is pretty good.
Yeah, that actually leads us probably to the next thing I wanted to talk about. I mean, from your experience, did you have these cases where, you know, there was a requirement that the model would be interpretable in some way, or maybe there was a specific requirement that, you know, it can't have some sort of bias that, I don't know, some sort of requirements on the model that, you know, you're about to develop? I mean, do you have some examples like that, maybe from?
Well, so we've definitely thought about that because a lot of our, you know, Red Hat's customers are in regulated industries where they need to be able to explain why they're making business decisions. We, you know, working with internal customers, they haven't been regulated in that way, but it seems like everyone on the team has basically been aligned that like an interpretable model is a good thing.
Okay, so what would be the acceptable interpretable model for them? What would that be, like linear regression, or? Well,
so this gets onto a topic I really like. I think linear regression. Who here believes linear regression is an interpretable model?
Well, I guess you can understand, like you put it on the paper and you see the line, right? Or
you see a line, right? And you know that like this feature, you know, contributes this much to the line. But does that tell you?
Well, I guess what you see is that there is not much more behind it, right? Like there is no like something hiding in the back that you haven't considered, and you just see it plain on the paper. Maybe that's it, right? I mean, from my perspective.
It's definitely easier to understand what's going on. I guess I want to sort of push back against the idea that it being easy to understand what's going on should be our goal with interpretability.
Okay, so what would it be the...
This is a lofty goal, so forgive me, but my goal for interpretability is that an interpretable model tells you something about the world.
Okay, but not about the model itself. Because I understand every model would tell you something about the world, right? So if you have a prediction model, it should predict something based on the data, right? So
so think about a decision tree.
Okay.
Right. Say you have a decision tree for fraud detection.
Mm-hmm.
Right. Say you have a decision tree for fraud detection. Right. Say you have a decision tree for fraud detection. Right. Say you have a decision tree for fraud detection. Right. Say you have a decision tree for fraud detection. Right. Say you have a decision tree for fraud detection. Right. Say you have a decision tree for fraud detection. when you train this, the sorts of questions that you ask will tell you how to discriminate between cases that are fraud and not fraud. You can look at this as someone who runs a payment processor, and you can look at this and decide what sorts of fees to charge people based on what kinds of transactions are more likely to be risky. You can what's going to result in a chargeback. I don't know that a linear regression model necessarily. I think about like renewing life insurance. People have life insurance. Do you have to do a questionnaire? Did you have to answer a lot? Get some. Is this a thing? Life insurance?
Yeah.
Yeah. So they take a bunch of tests which are correlated with how bad of a risk you are, and then they ask you some questions.
Yeah.
And I was fascinated because the only questions they ask you when you, at least in the U.S., when you get life insurance, are: do you skydive? And do you plan on getting a pilot's license?
Just 2 questions.
Yeah. And I said, well, I race bicycles. My wife and my mother are always worried about that. No, that's not a problem.
I like guns, right? Or
Yeah,
don't know.
I mean, any of these things, right? Like, and no, it's just skydiving and pilot. And like, I'm sure if you look at the regression model that the actuary is using,
someone
those are
wants
the
to have it interpretable,
only
right?
important factors, right? But like, does that tell you like how you should? I mean, does that tell you how you should change your life if you don't want your life insurance company to pay your survivors? It doesn't, right? Unless you're a pilot.
Okay. Yeah. So it's So I don't see what would be an interpretable model, because I actually don't have an example. So no one came to me and said, oh, it has to be interpretable what you're doing, right? So that's why I'm not sure how it would.
So, like, I believe what we mean by interpretability, like linear models, like you can actually look at the model weights and you can understand, okay, how each factor is playing out. But if you're using something more sophisticated, like, I don't know, the popular XGBoost, right? And what you would do there, like you do some residual analysis after the modeling, so what it gets right and what it gets wrong. And then you do some sensitivity analysis to understand the model behavior. So I think you don't have like an exact answer for many state-of-the-art algorithms right now, that it's not really clear, crystal clear. But you have ways to understand like how it's going to behave, at least in different scenarios, right? That's why you have like other kind of analysis. So I think the question is more like what we mean by artificial intelligence. So its promise, it's like so unreal, right? That's why we are using a term at IBM, like it's not artificial, but it's augmented intelligence. So we are augmenting the people who are actually on the ground, right? So all of these tools that we just to create, for example, in the healthcare, like regulated industries, like William mentioned. So if a physician spends an hours just going through those CT scans just to make a diagnosis, so we take it as like it should be like an augmented intelligence, so that it will really tell you where to focus, where to not, or it will just scan all database of like medical articles and it will find you the relevant cases. So you as a person can do your job much better than you were in the past. So that's actually how I'm looking at the like all of these applications around AI and data science. And I know that we have this techno-utopian club in Silicon Valley that they have super futuristic ways of technology. I mean, I don't have anything against that, but the reality, I think, it's really making people's work more efficient, right? Just finding near-optimal solutions that would work well for them. So that's how I look at it, like model interpretability, or the models that we can understand well or not understand well. Yeah, so this is the basic idea. Like you should really understand the kind of limits of your model. How much it's complicated is, I mean, another question, right? When you look at the deep learning models, convolutional neural networks, you can understand them up to some level. I mean, you can look at the outputs of every different layer, right? Then you can see what this model is doing step by step. But the idea is really like we have a lot of adversarial examples, right? Just to test it, like torture it, and then you will see like have an idea about the boundaries, what it will or will not do in the production. Yeah. So and you have industries like aviation that there is no like tolerance for a mistake, right? But I know those guys are using tools like technologies like deep learning, right? and they can successfully deploy these models to actual flying planes. So I think, so I see a lot of applications that it's being using confidently. So I don't think it's like a major problem for everyone to have like, yeah, really have 100% interpretable model, but it's more like what is acceptable or not, I think.
Yeah, so I guess to summarize, it would be if you understand your model enough to be confident that it's going to work. So you understand what it's going to do, right? Or the limits, as you said, right?
Yeah,
So that would
yeah.
be the sort of thing. Okay, it's slightly vague, I guess, but yeah, I mean.
One more thing that I've seen, and not from customers, but just from people I've interacted with in communities, if you have someone in a regulated industry, a lot of times they're going to use techniques that are less interpretable, right? Things like deep learning, boosted trees, to solve problems that are not on that sort of regulated critical path of their business, right? Like if I run a mortgage lender, or if I mean something higher touch than a mortgage lender, but if I have to make lending decisions that are that need to be explained and regulated, and I also have a way to route customers to the person who can help them with their problem, maybe I'll have like a really complicated but really effective way to overfit how to send customers to the right person to help them with their problem. And that creates, a better customer experience. That's what people are ultimately competing on, right? In these regulated industries, there's not as much room for innovation in the core business, and you can sort of innovate around the core business. You can be more efficient. You can provide a better customer experience. I think that's really, there's a lot of opportunity for AI there, and you don't have to boil the ocean either. You can really make a small improvement and make things a lot better for your customers.
All right, guys. I think probably we're sort of running out of time, but thanks a lot. That was a really interesting discussion for me, at least. I hope for you guys it was also pretty good.